question was mercuric acetate, H2O, NaBH4 and OH minus. So this is just a Markovnikov's hydration product, so that OH comes over here. And second one is aqueous KOH, so replacement of this halogen. So it's a nucleophilic substitution reaction. We get this molecule. And third compound is so it gives the anti-Markovnikov's hydration product. And next one is lithium aluminum hydride. So here lithium aluminum hydride will reduce both of these functional groups to alcohols. And fifth molecule is H plus and H2, just hydrolysis of the ester. Whenever you do the hydrolysis of the ester, it just split this C double bond O bond and gives the carboxylic acid and alcohol. So pH CH2 COOH plus CHOH CH3 and CH3. So now let's see the sixth molecule. So in this sixth molecule, OCH3 is there, HBr. So regarding this molecule only I will give the answer, but explanation will be done in the other's lesson. Here we get the phenol plus CH3Br. So these are the products of the questions of the previous day session. So today's session is about the physical properties of alcohols. So let's discuss some physical properties. We know that alcohol is having ROH part. Since ROH part is there, OH part is there, it can form the intermolecular hydrogen bond. Due to this, alcohols are having the abnormally high boiling point. than the ethers. Where ethers, they don't form the intermolecular hydrogen bond. And first three alcohols are highly soluble in the water. Highly soluble in water. The reason is, if you see this alcohol part, ROH part, this OH part is called the hydrophilic part. Means because of which alcohol is soluble in the water. But this alkyl part is called the hydrophobic part. So this alkyl part generally do not dissolve in the water. So when the size of this alkyl chain increases, hydrophobic part chain increases, so the solubility of the alcohol usually decreases when the chain of the alcohol increases. Now let us see how the boiling point varies among the different alcohols. So among the alcohols, the isomeric alcohols, when the branches increases, boiling point decreases. So primary alcohols having the higher boiling point than secondary, tertiary, means having the same molecular formula. So when the number of branches increase, their boiling point value gradually decreases. This is a normal concept. Our main concept is about the chemical properties of the alcohols that we shall discuss now. So these are the important concepts regarding the chemical properties of the alcohols. So in the chemical properties of the alcohols, first of all, let us see acidic nature of the alcohol. And here in the physical properties, I forgot to inform one particular thing, that among the alcohols, methyl alcohol is so poisonous. If any trace amount of the methyl alcohol is present in the water, it may lead for the loss of the vision. So the person becomes the blind. So methyl alcohol is poisonous in nature, and rest of the alcohols are not so poisonous. So methyl alcohol should not be present in the our food content. So now chemical properties, alcohols, acidic nature of the alcohols. Alcohols are acidic in nature because ROH part, if you see this ROH part, where oxygen is connected to the one side carbon chain, the other side hydrogen, both are less electronegative than the oxygen. So because of which oxygen always gets the partial negative charge, and here hydrogen gets the partial positive charge. So whenever any particular base is added to this alcohols, this oxygen is ready to pull the electrons towards its side and to release the H plus ion. So that after the loss of H plus ion, it forms the alkoxide ion plus H plus ion. So the acidic nature of the alcohol depends on the stability of the alkoxide ion. So if you take the different alcohol, let us take the different alcohols here. CH3, CH2, OH, next CH3, CH, CH3, OH, and CH3, CH3, OH. Now let us take the three different alcohols. We know that these alcohols, one is the primary alcohol, second one is the secondary alcohol, this is the tertiary alcohol. So when this primary alcohol lost the H plus ion, so it forms the C2H5, means directly I'll write the normal structure, CH3, CH2O minus ethoxide ion. Here after the loss of H plus ion, it can form the CH3, CH3 isopropoxide ion, and after the loss of H plus ion, here it forms the tertiary butoxide ion. You must be very careful because this explanation is so important to you to understand two different concepts regarding acidic nature and basic nature. Okay, so in this particular case, imagine first I will take the tertiary alcohol. After the loss of H plus ion from the tertiary butyl alcohol, we got this tertiary butoxide ion. So this tertiary butoxide ion, if it is so stable, then we can call this alcohol is a so strong acid. Let us see whether it is stable or not. I have discussed so many times that less the charge, more the stability of a particular ion. Here three electron releasing groups plus I groups are there. So they keep on releasing the electrons so that the electron flow will be towards the oxygen. So oxygen still gets the more negative charge so that it becomes unstable. Okay, and in this case only two are there, in this case only one is there. Means the primary alcohols, after the loss of the H plus and they form their respective alkoxide ion, which is stable than the secondary alcohols alkoxide ion, which is stable than the tertiary alcohols alkoxide ion. So that is the reason why primary alcohols are so strong in acidic nature than the secondary alcohols. Secondary alcohols are strong acids than the tertiary alcohols. And when it comes to the basic nature, this is so unstable, tertiary butoxide ion. So what it will do immediately, it will try to accept the H plus ion to neutralize its charge. Means it is accepting the H plus ion as early as possible. So H plus ion acceptor is called as a base. So when you compare these two, here this particular molecule is ready to accept the H plus ion more readily than this one. Means the basicity of the tertiary butoxide is more than the isopropoxide ion, more than the ethoxide ion. So this is the basicity order and this is the acidity order. Now the question is about the how alcohols, how to understand whether alcohol is an acid or base. A very simple thing that you just subject this alcohol, any alcohol you take. So when the alcohol is subjected with any metal or metal hydride, I am writing all the concepts here only. So one particular reaction, if you remember or write down in your notebook, that's enough. Metal hydride or organometallic compound. Organometallic compound. So you take any of these particular reagents and subject with alcohol. Alcohol immediately loses this H plus ion to the metal. If any metal is present in that particular molecule, it immediately loses the hydrogen. So it liberates the hydrogen gas. And afterwards it forms the metal alkoxide. This is not the covalent bonds. 1 minute. This is the metal alkoxide depend upon the charge of the metal. Here if it is the two charges there means two alkoxide ions will be there. Okay. So this is the metal alkoxide and the hydrogen gas. So any compound after reacting with the metal and its respective compounds, if it is releasing the hydrogen gas, such type of the compounds are said to be acids. So this is the important reaction for you. Only this much you remember. Now let us take what does it mean by metal, metal hydride or organometallic compound. I'll take some examples here. So I'll take the alcohol here. You subject with this sodium. So it forms sodium alkoxide plus hydrogen gas will be released. And take the alcohol and subject with the sodium hydride. So again it forms the sodium alkoxide and liberates the hydrogen gas now, because here hydrogen, here complete hydrogen will come. Now take the alcohol and take the organometallic compound like a Grignard reagent, say RMGX. Okay, so it will lose this hydrogen to the alkyl part so that alkane will be formed, and later this metal part will be connected to the oxygen, ROMGX. So here it is losing the H plus ion primarily, so that it is called the acid even in the case of the Grignard reagent. So not only even Grignard reagent, you can use a different type of the organometallic compound such as methyl lithium. If methyl lithium is used, this methyl part, alkyl part always which is in the organometallic compound takes the hydrogen of the alkoxide ion, so that we get the lithium alkoxide plus methane. Okay, so these are the best examples for the acidic nature of the alcohols. Even so, here I had described both acidic nature and basicity of the alkoxide ions, because this basicity of the alkoxide ions are so important in elimination reactions. So this has to be remembered. Now let us take the reaction of the alcohols. Now I am going to discuss one of the most important concept of the alcohols. Generally, you don't get this type of the discussion anywhere. So, reaction of the alcohols with acids. So, what must be the products when alcohols react with the acids? Different type of the acids you should understand here. That is, when alcohol react with, I am writing here the compounds like a concentrated H2SO4, second one H3PO4, take the acid salt potassium hydrogen sulfate, and take the some other acid reagents also like POCl3 in the presence of the pyridine. Means these are the protonic acid, these are non-protonic acids. And P2O5, heat it. And sixth one is Al2O3, heat it. Okay, I'm going to discuss one of the fine concept of this alcohol's reaction with the acids. Seventh one is hydrogen halides like HX I'll mention here. So in bracket, it may be HCl, it may be HBr, it may be HI. Even if you use the zinc sulfate, zinc chloride, anhydrous Cl2 with HCl, even this combination is also acid is involved over here. That's why I am writing this one. Now, ninth one is now PX3, 10th one is PX5, 11th one is SOCl2. So these are all different reagents which are actually acidic in nature. Then what must be the products when alcohols react with this type of the different acids? So that is our main concept in today's session. Okay, so you must remember that whenever alcohol reacts with the acids, it gives different products. See, when it reacts with the first up to here 6 acids, alcohol on reaction with these acids undergo dehydration. Dehydration means loss of the water molecule. Final products are alkene. This alkene also, as per Sedgwick rule. Sedgwick rule, or it is also called the J-Saves rule. Okay, what is Sedgwick rule? What is J-Saves rule means? A more substituted alkene is major product. More substituted alkene is the stable and major product. Okay, then what about the other acids? You must remember, because people get confused of this one only many times. Here also this is an acid, but these acid combinations, when any alcohol when react with any of these acid combinations, undergo nucleophilic substitution reactions, SN reactions. So SN reactions means halogen, here chlorine, bromine, iodine, chlorine, here based on the type of the halogen you are taking. So it replaces the OH part, so that you will get the RX, haloalkanes. Anyhow, a great discussion is ahead. We shall discuss more about these concepts, but I'm giving you overview of these reagents, how these reagents work, because students always get confused how to understand each and every reaction, why many reactions are there in organic chemistry, and what is the nature of each and every reagent, because they discuss separately about each and every reaction during the classes, but here we are discussing about the reagents together so that you can understand it clearly. Now here I have to give one more important thing, that whenever first reagents you are using with alcohols, no doubt they give the dehydration. So dehydration is common. Loss of water molecule. Alkene is the product, no doubt, again Sedgwick rule, but it is formed, it is a rearranged product. You might have understood that rearranged product when I am using this word, the intermediate is carbocation. And when you are using these reagents for dehydration process, no doubt you will get the alkene again, but without rearrangement. So when you don't want to rearrange a particular alcohol and you want the product without rearrangement, gives the Sedgwick product. Both will give the Sedgwick product only, but first three gives the Sedgwick product after the rearrangement. Last three gives the Sedgwick product without any rearrangement. And regarding these particular reagents, we shall discuss in the coming discussion. But basically, whenever an alcohol is subjected with these reagents, the product is haloalkane. So now our discussion about the dehydration. Dehydration of alcohols. So dehydration of the alcohols with I am taking first three reagents, concentrated H2SO4 or H3PO4 or KHSO4, because most of the persons are unaware and they discuss most about the concentrated H2SO4 and they stress to some extent on H3PO4, but in examination they are concentrating on the potassium hydrogen sulfate, which is also a finest dehydrating agent. Then how the dehydration process of the alcohol takes place, that we shall discuss mechanism. Then we shall go to the next type of the dehydrations. Okay. So first mechanism. Let us take a particular alcohol. Subjected with the acid. Acid in the sense any of these combinations. So protonation takes place. Here lone pair of electrons are the lone pair of electrons attract this H plus ion. So that here CH2, CH, R, OH2 positive charge, next loss of H2O. Okay, so that R, CH2, CH, R positive charge. Now maybe rearrangement or else loss of the proton. So loss of H plus ion. So the molecule now gives CH double bond CHR. Okay. So here carbocation is formed, so that if it is secondary carbocation, if there is a chance for the tertiary carbocation, so from here onwards a shifting takes place, and H plus ion coming in this particular reaction is from the beta hydrogen, not from the H2O molecule, so that you should understand. So in this particular context, OH and hydrogen are removed from the adjacent carbon atom. So if it is the alpha carbon atom, this is called as beta carbonation. So this is called the beta elimination. Okay. Now the same reaction I'll explain with another mechanism. R, CH2, CH, R, OH. First of all H plus, same protonation first step, so that R, CH, CH, R, O, H2 plus. Now this H plus ion, this sigma bond electrons will shift here, and here these electrons will go there. Means at a time H2O and H plus ion will be eliminated, and finally giving RCH double bond CHR. Then what is the difference between these two mechanisms, and which alcohols gives first mechanism and which alcohols gives the second mechanism? So if you understand SN1 and SN2 reactions, in SN1 reaction there is a formation of the carbocation, right? So wherever the carbocation formation is there, that is generally in a nucleophilic substitution reaction. It is called a SN1 reaction. So this is a type of the SN1 reaction. But in the case of the elimination reactions, this reaction is called the E1 reaction. SN1 reactions for the substitution. For elimination reactions, the reaction which involves the formation of the carbocation is the intermediate are called the E1 reactions. And here no carbocation is found, but at a time there is a loss of both the molecules. So this type of the reactions are called as the E2 reactions. So E1 reaction and E2 reactions. Now the question is about the which alcohols follow the E1 mechanism, which alcohols follow the E2 mechanism. So you have to remember only one particular thing, that both secondary and tertiary alcohols, both secondary and tertiary alcohols with these three reagents, they follow the E1 mechanism. Meaning there is a formation of the carbocation whenever you are using the secondary tertiary carbocation, because I'll give some questions for you to solve. So there may be secondary alcohols, tertiary alcohols with this concept. So in such cases you have to remember that there must be a rearrangement. And primary alcohols, they follow the E2 mechanism. E2 mechanism means no rearrangement, only from the side carbon one hydrogen will be removed, so that H2O and H plus ions will be coming out at a time, so that we get the alkene. So in both the cases the product is alkene as per the Sedgwick rule, but in the first case it is the rearrangement, in the second case no rearrangement when pure primary alcohol you are using. Okay, so now let us see, pure primary alcohol means primary alcohol will be there, but at the same time if there is a chance for the formation of the next carbon, any tertiary carbon atom or any other carbon atom, again we have to see for the rearrangement. But to some extent, let us see here. I'll take example for each and every one. So first of all, I'll take the example for the E1 mechanism. So again and again I don't discuss the mechanism. So E1 reactions example. So in the case of the E1 reactions, I'll take one example here. OH, so that a concentrated H2SO4, heat it. So this is a tertiary alcohol. So you can easily expect the rearrangement. Rearrangement means here rearrangement is not necessary. So the products are, this is the major product, because this side it will be formed major product, which is the more substituted alkene, and from this side also there is a chance for the loss of the hydrogen, so that if double bond is found between these two carbon atoms, then we shall get the molecule like this, but this is the minor product. Second, let us take another example. Concentrated H3PO4. So H3PO4 work is also like the H2SO4. So you don't bother about that. So here hydrogen may be removed either from here or from here. You take it as a hydrogen. or from here. Anyhow, these two hydrogens are same, so that hydrogen can be removed from here, this combination or this combination. If you remove these two hydrogens, double bond will be here or else here. So you know that which is the major product. I'll write down both the products. You just tell me which is the major product here. This is the major product and this is the minor product. I'm taking all the E1 examples initially. Later we shall discuss the E2 examples. So concentrate H2SO4. You might have observed that I'm using only concentrate H2SO4 and H3PO4. Generally for lecturers it is easy to use. They forget about the KHSO4, but it has its own importance that you should not forget. So this is the major one. This is the minor product, because here from here hydrogen has been removed, not from here, because if you remove from here we get the highly substituted alkene. And you know, you can watch our videos regarding the alkenes chapter, because completely we had given which is the major product, which is not the major product, and why. And actually here we get this type products. Now let's take on one more example. This is the one. So H plus ion. H plus ion in the sense H2SO4. You must remember every time that. Okay, anyhow. Concentrated H2SO4 and heat it. So that the products, what are the products here? So in this 64 percentage of this category, 33 percentage of this category, and 3 percentage of this category. And people generally get the confusion about how these three products, actually this product they don't expect, though it is a considerable percentage. They expect either rearranged product or this product. This product is also formed. So we shall see the mechanism only for this reaction so that you can understand. You just see this is the OH. H plus from the H2SO4, so that lone pair of electrons attack over the H plus ion and they make OH2, which is where there is a loss of the H2O. So that anyhow this is a secondary alcohol, so that there is a chance for the formation of the carbocation. Now here methyl shift takes place. CH3 shift. Methyl shift means this methyl group completely will be shifted over here. Then we get the here this carbon atom will have the two methyl groups. So this is the carbon with the two methyl groups. And since this group is being shifted here, this positive charge will be shifted here. So positive charge, and here already one methyl group is there, new methyl group is coming. So this is the structure. Now the question is about how the products are coming. Now the product is, see here, if hydrogen is removed from here like this, we get this product. 3% is product, which is the less substituted alkene. And let us see about these two products now. Okay, so if hydrogen is removed from here, then you will get the double bond here and get this product. This 33% is product. Okay, and if hydrogen is removed from here, then you get our major product. So I'm using the different color pens, colors for the different products. 64%, 33%, 3%. But basically this is the major product that you have to remember. Now let us see some other beautiful examples of this E1 mechanism. constant H2SO4 and heat it. You can take H3PO4 also. So the products that are being formed in this particular case, this is the one product, second product, third product. Among all these, this is the major product. These two are minor products. Anyhow, ring expansion is involved. So for this also I'll explain the mechanism. I'll take mechanism very fast so that we can cover the concepts. I think you are understanding what I am explaining. Formation of the carbocation and later shifting of this bond, ring expansion. So when ring is expanded, generally people get confused of this. You must remember where this ring is going to expand, to this carbon atom. So you just give the numbering to this carbon atom. 1, 2, 3, 4, 5, 6. So it is going to be form a 6-member ring. So in this 6-member ring, first carbon atom is having the positive charge, but that positive charge will shift to the second carbon atom. Why? Because the second carbon atom is losing these electrons to the first carbon atom. So that you just assign any of these carbon atoms as the first carbon atom. If you assign this carbon atom as the first carbon atom, then automatically it becomes the second carbon atom. Second carbon atom will get the positive charge, and first carbon atom there is a methyl group, like this. Okay, and now hydride shift takes place. I'll explain the reason. This is the secondary carbon, and here hydrogen is there. This hydrogen, if it is shifted over here, then we get the tertiary carbocation, which is more stable. So from here you will get the two products. If hydrogen is lost from this particular area, so this red circled hydrogen is if removed, then pi bond will be formed here, so that the product is, I'll tell you later. And if green colored hydrogen is removed, so pi bond is formed over here. So these are the products. So now you see, this is the major product we got, okay, and this is the one product we got here. And from where this particular product is coming, this product possible from this particular reactant. If hydrogen is removed here from here itself, so we get the, sorry, if hydrogen is shifted, 1 minute, not the H plus ion, hydrogen is shifted. So if hydrogen is shifted from here, H minus is shifted, then here we get the secondary carbocation, and if there is a loss of H plus ion here, there is a chance for the formation of this molecule. Many are there, means you can remove even hydrogen from here also in such cases. So then there will be one more product. These are all meaningless and very less important products. And here if hydrogen is removed here, then you will get one more product. But considerable products only I have written. So these are all chances are there. But among all those, these are all minor products. The major one is this one. Now, let us see some other reactions also. Generally in dehydration reactions, how the other reactions are coming, best examples. Because in previous NEET examinations also, if you observe, this type of the reactants are there. Reactions are there. Concentrated H2 SO4 and heat it. Everyone knows that H plus H2O will be removed so that this pi bond will be formed, alkene molecule will be formed, but the products are different from our expectation. This is the product. This is the only major product. So how this product is formed means again mechanism. So mechanism means here I'll write fast mechanism. So here OH, H plus. So directly I am writing the loss of H plus H2 also. So carbocation. Now ring expanded here. RE, ring expansion. Ring expansion means it becomes 1, 2, 3, 4, 5, 6, 6-membered ring. 6-membered ring means here I have developed the 6-membered ring that I rotated, so that I am getting here. So in the 6-membered ring, so after the formation of 6-membered ring here fused carbon atom is there. Fused carbon atom is losing the electrons bond to this carbocation. So here new bond is coming, and both of these carbon atoms are in the part of the new 6-membered ring, so that if you put positive charge here or here, there will be no difference. And remove the H plus ion here, so that we will get the alkene like this. Now let us take another beautiful example. So for this example, you only send me the mechanism. I'll give the product. But this was asked in the previous examination also. Concentrated H2SO4. But if you see the pre-examination question paper, you will get confused of this question, because there will be 3 similar options and you get confused. But I am giving only single option here. So get the mechanism for this particular product. And regarding the important concept, very important concept of this even mechanism. Note, rate of dehydration. Rate of dehydration means which alcohols generally undergo dehydration easily. So we have clearly discussed initially only that even reaction is for which alcohols? Secondary and tertiary, means the alcohols which are able to form the carbocation can easily participate in the even reactions. So here tertiary alcohols can easily form the carbocation. So rate of loss of H2O is more for the tertiary alcohols than the secondary alcohols, than the primary alcohols. Okay, so I'll give this example also here. So if anybody asks you among these alcohols, from which alcohol we can remove the water molecule easily, means tertiary, secondary and primary, because tertiary alcohol generally forms the carbocation easily. And if cyclic compounds are there, you see very important thing, I had made one video also about this one in previous videos. You can search for that also. Even today also we shall discuss once again this alkenes topic. We had discussed this important concept. So these are all different alcohols. When there is a conjugation of the alcohols and after the loss of the H2O molecule, if any conjugation is being developed, if new conjugation is going to develop, then that particular alkene, that particular molecule alcohol can easily lose the water molecule. So here it can easily lose the H plus and OH, so that benzene molecule can be formed. Later here isolated alkenes, and here normal alkenes. So conjugate alkenes conjugated alkene. This is also conjugated alkene. It means conjugated alkene after the dehydration. This is conjugated alkene with dehydration. Even if you lose the water molecule, before also there is a conjugation. After the loss of the water molecule, you get the again a conjugated alkene. But normal alkenes where there is no pi bond at all, then that molecule generally undergo, though these are all secondary alcohols, their rate of dehydration is less. Even if you take this molecule also, H2O, there is no much difference between these two molecules. Why? Because here conjugation will not be developed. So again, a shifting of the H plus ion has to take place to develop the again conjugated alkene. Now, let us see another type of the alcohols, primary alcohols and all these, primary, secondary and tertiary in the cyclic compounds. So if you take the cyclic alcohols like this, so this is a tertiary alcohol, this is a secondary alcohol, this is a primary alcohol. Rate of dehydration of alcohols is like this.